Alright guys, in this video we're going to just take a quick look at determinants of matrices and how to find them for 2x2s. Just a couple quick examples. We'll kind of go through quickly what they are, how to find them, and do a few examples. So let's get to it. So first of all, determinants have a lot of different uses mathematically. We're really just looking at the tip of the iceberg for our particular class, but for us, a couple things I just want to mention. They tell us about the solutions to systems of equations, and they also tell us whether inverses exist, and we'll talk about these things in class. But for right now, we'll just focus on finding determinants and how to go about that process. So let's look at, this is the general notation. If we have some 2x2 matrix, A, B, C, D, then a couple notational things. So number one, we can denote the determinant of that matrix a couple different ways. The first one is just the determinant of A, so it's a little bit of shorthand. The second one is with these straight bars. They're called almost like absolute values. So just straight bars mean determinant. And so it's a small thing, small notational thing, notational difference from our regular matrix notation to be aware of. So a couple notational things there. And so just moving on real quick, here's the general form of the determinant of a 2x2 matrix. So if you notice what's going on, basically what we're doing is we're just multiplying across this diagonal, and that is A, that's the top left, times the bottom right, times D. That product we're going to take, and then we're going to subtract the product of the other diagonal. And so when I multiply C times B, I subtract that product. So this is really a difference of products. But more generally, we just multiply the diagonals and then we subtract the second diagonal from the first diagonal, and that's how we find it. It's as simple as that. So let's go through a couple examples here just to give you an idea of what's going on. So we want to find the determinant of A. And again, couple different things, a couple different ways that we can write this notationally. So determinant of A is equal to, and I multiply my first diagonal, so I get 6 times 2, and I'm going to subtract the product of my second diagonal, so 11 times 1. And very simply, just go through, and order of operations tells me this is 12 minus 11, which is equal to 1. That's the determinant of matrix A, and that's it. Go through a couple more examples here. So I've got, in this particular one, I've got, let's use our other notation. So I want the determinant of the matrix 1, negative 3, 3, negative 7. Again, the straight bars indicate that I want the determinant. So let's just go through and multiply. So my first one is multiply along the diagonal. So I get 1 times negative 7. And I'm going to subtract the product of the other diagonal. So minus 3 times negative 3. Simplifying, I've got this as negative 7 plus 9 gives me 2. That's the determinant of that matrix for that example. Two more quick examples just so you have enough to kind of work off of. So let's go, the determinant of A equals 5 times 2 minus 3 times 1. And simplifying, we get 10 minus 3, that's equal to 7. And the last one, the determinant of A equals 6 times 2 minus 4 times 3. That's 12 minus 12, so that gives me 0. So there are some special properties, or kind of some special things going on with a couple of these, namely the fourth one that we'll talk about in class. But yeah, there's some quick examples of how to find determinants of 2x2 matrices.